Hey students, welcome back. We are on to enthalpy of formation. Whoops, that's not a highlighter. Alright, we're on to enthalpy of formation. This is 7.9. We do have a little homework today. We also have a new formula. It looks aggressive, but it's really not that bad. So let's kind of jump in and see what we've got here. Okay, so first off, we need to define what standard state is. All right, and standard state is like its natural conditions. All right, so what are these natural conditions? For a gas, we're talking about 1 atmosphere of pressure. All right, 1 atm of pressure. For a liquid or a solid, we're just talking about its most stable form. And we're talking about its most stable form at room temperature. So 25 degrees C and 1 atmosphere of pressure, because that's also like what we normally have pressure to be. All right. For a substance in solution, this is talking about a 1 molar solution. We have 1 mole dissolved in solution. All right. Now, standard enthalpy of change. So we've got delta H with the knot. That little knot right there is standard state. That tells us we are at standard state. So when you see that, either in this unit or units beyond, we're talking about standard state, which are these certifications up here. Okay, so standard enthalpy change, we're talking about the energy change at the standard state. At standard state. And we can do some things with that, which is what we're going to talk about here. We can talk about the enthalpy of formation. So how much energy does it take to form at standard state? All right. So for a pure compound, this is what we're talking about, 1 mole. We're talking about 1 mole. How much does it take? How much energy does it take to form 1 mole of a substance? For a pure element in its standard state. So if I'm looking at the oxygen in the air, if I were to see it, how much energy did it take to form that? None. So our standard state for elements in there, for pure elements, is 0. Their delta H of formation is 0. All right, and we'll actually use that kind of down below here. All right. So we're supposed to write equations for the formation of MgCO3 and C6H12O6 from their respective elements in their standard states. And then we're going to figure out what delta H not F is going to be. And we can find that in Appendix 1B here. We'll go there in just a little bit. All right. For that problem obviously below. So let's start off by this part. We're trying to form it. So we look at the elements in their standard state. So we're looking at A here. We're trying to form MgCO3, solid. Okay, again, states are important. So what elements make that up? Well, we start with Mg, right? And Mg solid, right? Then we add carbon. And we have to be specific on carbon, because what is carbon's standard state? There's kind of quite a few, right? We've got graphite, we've got diamonds, we've got Buckminster Fulleys. So we're going to say graphite here. All right, that's its most stable state and kind of the one we most find. All right, and then we have O, but oxygen in its standard state is what? O2. So we would have to say 3/2 O2, because we want to be able to make MgCO3, right? MgCO3 there. All right. And that would be our equation of formation for this problem. Hopefully that makes sense to you. And then we can look up and find delta H either in the table on page 290, or you can find it in the back of the book. So delta H, not a formation, for MgCO3 is negative 1095.8, and that's kilojoules per mole. We're going to actually use those kind of a little bit later. So let's change colors here. Now we're doing C6H12, a simple sugar here, O6, and it's a solid. Okay, so again, we start with carbon in our graphite form, but we need 6 of those, right? So we're going to put a 6 out front. Plus, this time we have H2, right? And that's a gas, so we need 6 of those to get us to 12. Then we need 3 O2s, gas, right? And that'll form us our simple sugar, C6H12O6. The key here is that we're always forming 1 mole, right? We don't want to form more than 1 mole, all right? Solid. And so then we look up and find our delta H of formation, and we get, for graphite, negative 1,273.3 kilojoules per mole. And yes, I was just literally looking it up in the book. It's right there. Glucose, or C6H12O6, is about the third one down in the middle column. Okay? Awesome. So let's see if we can't kind of use that to figure this out here. And this is where this formula comes into play. We're going to take the sum of the moles of the products minus the sum of the moles of the reactants. And again, we're just going to look up those formations in Appendix 2B, or they might even be on this page 290. We'll kind of take a quick peek for those first. But our first step is we want to take products minus reactants. So delta H. And what I like to do is I like to kind of break this down and write what I need. So I'm going to I need 4 moles of NO plus the 6 moles of H2O. And this is a gas. I should probably include that. All right. And then I'm going to minus my reactants, 4 times my NH3 gas, plus 5 times my O2 gas. And we'll get to, hopefully you guys are sort of already seeing this here. So let's look them up. We've got 4 times NO gas. Sometimes it's hard to find these babies. There it is under the nitrogen. NO gas is 91.3. So we've got 4 times 91.3 plus 6 times, this one's going to be, and it's gas. That's why it's important, because we've got both gas and liquid there. So we've got negative 241.8, negative 241.8. And then we've got minus, and we've got 4 times NH3 gas. That's going to be under our sodium. There it is. Negative 45.9. Anybody see anything tricky coming up? 5 times my oxygen. Is it in there? Oh, it is. It's 0. Why is it 0? Oh, that's because it's an element in its standard state. So all we have to do at this point is just add them up, or kind of whatever, do our little math magic, as I like to call it. And we should get, right here in this one, we'll get negative 1,085.6 kilojoules. And then we're going to subtract negative 183.6, which is actually going to add, right? And so our overall here, delta H not of formation, is going to be negative 902.0 kilojoules. Awesome. Hope that works for you. See you next time.